all to today's webinar on design and development of electrical vehicles using ANSYS. It's very effective and need to have knowledge related to electric vehicles because new era of electric vehicles is already accelerated globally. I would like to introduce our today's expert, Mr. Kartikesh Kumar Jha sir. Sir is working as application engineer in ARK Info Solutions Private Limited. Sir has also worked as junior research fellow under the project entitled Design and Development of Low Cost BLDC Motor Drive for Solar PV Irrigation System. Regarding education, he is pursuing his part-time PhD in electrical engineering at National Institute of Technology, Patna, Bihar. Sir has completed Master of Engineering in Electrical Department from Birla Institute of Technology. Sir has completed BTech in Electrical Engineer. Now I would like to invite our today's expert to deliver today's webinar. Welcome, sir. Once again, over to you, sir.
Okay. Thank you, sir, for giving me such opportunity. So I have welcome you all, and I am Kartikesh Kumar Jha and working as a application engineer at ARK Info Solution Pune. So let me share my slide, and then I will begin with that. Okay. Is my slide visible?
Yes, sir.
Hello, sir.
Yes, sir. Yes, sir.
Okay. Thank you, sir. Thank you, sir. So today in this webinar, what we will basically do, we will basically design and development of electric vehicle. We will comes to know about what was the challenges we face when we are going for designing our electric vehicle, and what was the things and how we can overcome these challenges. So these things we basically address today in this webinar, and how answers will basically help you in your solving your problems and challenges. So that thing also be addressed today. So first I will introduce about something in about ANSYS. Like ANSYS is nearly 2x to the size of the nearest competitor, and ANSYS is basically number one in simulation, and it's capable of 4,800 employees and committed and well focused in the simulation market. And what ANSYS basically provides you, ANSYS is a continuous simulation tool. By using that, a pervasive simulation method is basically given, and you can also use that pervasive simulation method for the continuous simulation with all the physics across the entire life cycle for all projects. Like you can also go for ideation of your project, and in ANSYS discovery part, you just lock your idea, and at that locking your idea, you will be able to come to know that that will basically reduce the 80% of the cost. And after that you just go for production, and in that process you just go to that ideation to design part, and that design part will also be reduced your development time to 9x time by using the ANSYS. And that will also help you for the manufacturing and operation and creating your project. Like if your prototype of your project will be created in less time if you use that ANSYS products and ANSYS simulation method, because simulation basically reduced your time. And if you want to change any component in that the whole electric vehicle system, so you can change it by using this. And then after going to that, we will have a ANSYS solution for electric vehicles. Like you can see here, a virtual lab can easily be assessed at any time, anywhere, at any skill level. We can change it by using ANSYS software. Like you can see here, what you will do, You can you if you want to change your vehicle battery system, so you can change it. Like if you want to go to from lithium ion battery to other things, so that thing can be easily done using this software. And if you want to change from your traction motor used in electric vehicle to permanent magnet synchronous motor or SRA motor, so that can be easily done using this. You can also do the multi-physics or multi-physical analysis like fluid dynamics, structural mechanics, electromagnetic system, material science analysis. So these things can be easily be done in this ANSYS software. And the ANSYS basically divides the electric vehicle in four pillars. So we will basically divide it in four pillars like battery and battery management system, and after that we required a power electronics device for controlling the our electric motor. So next thing comes as a electric machine, and after doing that the whole system should be in a integration of the battery, power electronics and electric machine comes under the parts of electrified propulsion system. So we will categorize this as a battery and battery management system, power electronics, electric machine and electrified propulsion system. In that you will comes to know that what was the placement of the battery and what was the placement of your machine, so that will excel your uh, controlling part of the electric vehicle. So that will be also a very important point. And one more thing also considered is the main, when you are going to designing your electric machine, you will have to take care of acoustic noise and vibration and harness analysis that should be there. And for the battery part, like crash analysis, and if accident happen to your electric vehicle, so that part should be a very important. Like if any point of time your electric vehicle is running and if any short circuit in the battery is happened, what was the behavior and what was the condition of your electric vehicle, so that should be also a very important point, should be considered when you are designing your battery and the battery management system. And how that battery will behave, like what is the state of the charge. So these things will comes under the battery part and battery management system. And the power electronics will basically help you in deciding the thermal, structural and electromagnetic and parasitic calculation, and what was the value of the current and what was the over protection for the voltage and the current. So these things comes under the power electronics part. And after that, if you are using a automotive electric vehicle, so that would be like if you are giving a signal to the electric vehicle like a stop or on, so that signal would not be deteriorate by the other electric vehicle system and the other noise present in the cloud. So that should be also be taken care by the embedded software or electrified propulsion system will be there, and one functional safety will be provided to our electric vehicle. So I will discuss this one by one. Like first we will go for battery and battery management system, and that subcategorized this. And we will comes to learn about the electric machine, like how to design that electric machine, and then we will go for power electronics, and then we will combine these three in a system integration part. So let's go to that battery and the battery management system. In battery and the battery management system, the one of the most important thing we have to consider for the battery is the power density of the battery, or we have to consider that what was the temperature of the battery, and the third thing we have to consider what is the life of the battery, and what was the size to weight ratio of the battery. So these things is very important when we are going to designing the battery. So for that, what we required, we basically required some knowledge about the cells and the electron performance, and then we will easily design our cells, and that designed cell will be converted to the model. So that for that we required a thermal and mechanical team to make that model or the pack thermal management system, and that will basically help in the creating the battery structural reliability. Okay, and after that we required an electrical team for EMI and EMC analysis, like designing a electric filter, filter design, shielding, and the component selection. And then we required software system people, so that will basically give us a battery management system and battery integration part. And then we will go to one by one, like how to do that cell part. In cell part, you can see here, using that ANSYS, we will easily fast process our meshing of the cell. And what was the main goal? Why we have a main goal of energy and power density from the battery. So that thing we have to be take considered. Like you can see here, a 3D model predict, like one published paper is there in Elsevier that predict that the 3D model basically predict the global discharge characteristics that is consistent with the experimental value. So they have designed it in ANSYS, and after that they have compared with the hardware, and they are getting nearly a same result and the consistent result with the experiment. So that ANSYS will basically help you in predicting, understanding, and minimizing the weight or volume ratio by optimizing the packing density. And then come to the thermal management part of the battery. Like what you want basically from the battery, we are basically making our battery a cell, and after designing the cell, we will have to put that cell into end plate mesh. So after that a model is created. But if you designed your model, and if your model is connected, and after that we have to check the temperature contour of and the current density contour of the model battery. And when you will come to know that, like if anything is more heated than the other part in the battery, like hotspot is created, you can see a red color. If the red color hotspot is created, so how we will remove that? So that is a very challenging task for the battery management, so battery creation and the battery system problem. So for that we basically use ANSYS Fluent and HPC and ANSYS Fluent meshing method, so for calculating the value of temperature. And by using that, we will basically easily able to design the cooling system for that particular battery model. So you can see here, like air cooled method is presented here. In that, what we have designed a battery cell, and in that we use ROM, reduced order modeling. And in that reduced order modeling, what we basically doing, we are just making our battery and changing our battery to a equation of a battery, electrical ECM model. And in that equation will be connected as a model of a battery, and that will be given as for the thermal coupling, and from that we will get a result like this. So this will basically reduce our timing of the simulation, first thing. And the second thing, this whole process will be done in twin builder, and this will basically validate our battery sizing and cooling design to meet the requirement, and this will also accelerate design optimization performance. Like you can see here, the benefit is that optimized battery basically delivered a beating record on the target track by 16 seconds. And the next thing, you can also use liquid cooled system. Like you can see here, what we have designed a thermal model. In that thermal model, these red parts are the more heated part. So that model will be given to SML. Thermal ROM is the reduced order model, and from there, or electrical EMC model, both model will be transferred to the thermal pack, and from there we will see a heated, only one heated plate will be present in our model. So what we have to do, we have to take the necessary condition, and after taking the necessary condition, we will have to mitigate these things, and we have to concentrate only on that part of the battery system. And how we will do that, we will have to use ANSYS Fluent and ANSYS Twin Builder for doing these things. We have to mitigate this created red spot and the red hot part. So for that we have to make a perfect coolant fill system for this. And after going to this, like you have designed your model perfectly for the battery, the next thing what we have to consider and what we have to take in consideration is the safety standard. And what safety standard and how we will test that, we will have to do the nail penetration test and impact of the thermal runaway test. So thermal runaway test and the nail penetration test basically gives you information about a crash analysis, or if accident happen, how our battery will behave. So these things will come under the durability and the safety of the battery. So first you have to design that, and after designing you have to do certain test for the safety and durability of your battery. So that and one more thing we can also add here, like we will do the optimized housing design for the vibration and impact test also. And after designing, like my designed battery is perfect, so we have to check our battery will not be battery system or BMS performance will not be affected by EMI or EMC effect. So how this will be affected by EMI or EMC, like we are using inverter, we are using AC motors, and we are also using filters, so that will create some noise and the vibration will be created. So that noise of the and the certain frequency noise will not affect the performance of our battery and the battery system. That will also be considered when we cascade our whole battery system before the electric vehicle. And this will also help you in early detection and mitigation of the EMI and EMC effect. And this will also reduce your cost compatibility test, and you will also do the analysis like how to select the component for the battery, so that thing will be also be considered. And you have to create a trade-off between battery and the battery management system when you cascade the whole system with the motor and power electronics devices, so that behavior will also be considered. And when battery is designed and battery is working fine, then our next goal is to design the battery management system for our battery. Why we are required this? Because we have to check what was the state of charge of our battery. We also want to check the what was the state of health of my battery, and we have to also put some we have to also put some safety standard. Example, we can consider as ISO 26262 compliant basically. Okay, so what we have to do from, like you have designed your battery management system, so that management system will be exported to the CAD architecture and the CAD should present in the answers, so that will basically help you in visualizing your battery health and the battery's charge, like what was the value of the voltage it is delivering and what was the value of the current. So that thing will be exported to the CAD suite, and from that CAD suite you just import that software. By using that software you just export it to the VR experience, and from the tool builder you can easily able to model. And that model based software development will basically generate a automatic code generation is there, so that will also reduce your work. Like you don't have to go for coding and doing all the analysis coding designing, so that thing you don't have to go, and you don't have to worry about that. So that will be automatically done in the CAD suite, and the CAD will display your CAD should basically display your the result. Okay, so that will basically increase your time to market from 2x time. Like early detection can easily be performance, and the high performance and high quality code will be generated automatically. And from that you have to use a reduce order model, and then you have to just export it to the twin builder and we can analyze it. And the next part we basically focused after battery management system is completed, we have to go for validation for the real time client model, like how my behavior of my battery and the battery management. Like first we have created the battery, next we have created the battery management system, and after then what we are doing, we are just combining that two, and then we will check what was the behavior in the real time plant model. Okay, so for that what we have to use, we have to use the same software of the ansys fluent and ansys twin builder for that. And that will basically accelerate and maximize our performance. Like using that pack CFD, we will able to design the thermal and thermal design and thermal modeling, and we also do the EOCs like reduce order modeling. We will have to equivalent circuit model, we can easily design it for the battery, and that will be exported to the thermal ROM and the pack EMC. And from there we will come to know about the what was the transient dynamic behavior. Like you can see here, maximum allowed current is in red color, but and we if you are doing your analysis and if you are getting a result below that current, maximum allowed current, so that will be basically produce a good result. And if you are getting more than maximum allowed current, so that means your motor your battery and the battery management system is basically not working fine, or your motor wants more current from that battery and the battery pack, so that should be also be taken care. So that thing will becomes under the transient dynamic behavior when we are designing for battery management system validation for the real time. And the after designing, I will basically summarize the whole process. Like first, what we have to do, we will have to basically design using material and electrochemistry, and after designing, we will import that model in for the thermal and structural analysis. The next what we have to do, we will have to pack our for the electrical and the crash analysis in LS Dyna Twin Builder, and then we have to put it on the SCAD using and combine our battery with the battery management system in the SCAD Medni and Twin Builder. Then we will analyze our whole electric vehicle circuit there. Okay, and then the next part we have to go for electric machine design and development. In electric machine designs and development part, what basically we are focused on, like we want to improve our power density and the energy efficiency and operational life of a motor. So for that we are divided our teams like electric machine design team and CFD and thermal team. So what electrical machine design team will basically go and do the analysis for the electromagnetic design, thermal design, and advanced magnetics. And from there you will comes to know that optimized torque and speed characteristics and efficiency map is there. And then we will also come to know about what was the value of my torque density and what was the power I'm that motor will used, and what was and how to do that regenerative braking. So these things we have to be considered here. And the next we will go for the thermal team, and that thermal team will basically give us the what was the strategy we have to use for designing a cooling system, and what was the and how we will reduce the noise and the vibration of for the comfort of the passenger which is sitting in the electric vehicle. And then we have to consider and we have to check the comprehensive and what was the robust validation for the driving cycle. So that will be comes under the control and the software team. Next, we have to design our motor. So how we will do that? So we have two method we can easily go for. We have ready to go model or designed model is present in the MotorCAD, ANSYS MotorCAD. So that MotorCAD will basically give you a ready to model for many software, many other motors. So you just have to export it, and accordingly what it changes you basically want it, so you can change it there. And after changing your whole motor and according to your requirement or your research point of view, what you basically want to change it, so that changes you can easily done it in MotorCAD. And from there you can easily do the electromagnetic analysis. And in electromagnetic analysis you will easily do the temperature based electromagnetic analysis. You will also do the and predict the performance, so that thing will be comes under the EMAG. And after doing that you will go for thermal and mechanical analysis. In thermal and mechanical analysis you will basically able to predict the cooling system and stress and strain analysis. And then what next we have to do, we want basically a efficiency mapping and how my motor will perform for a particular driving cycle. So we basically have to we will in efficiency map, what we will do, we will just export one or import one model of drive cycle model on that, and then we will analyze it. And after that we can also do one more thing here. Like you have designed your model in motor ANSYS MotorCAD, you can export or import. Both thing can be happen with the ANSYS Maxwell. So designed and motor in the ANSYS Maxwell can be imported and exported simultaneously. And we can also do the optimization there. Like if you are created a motor and you are getting a efficiency of nearly 92%, and you basically want to increase that efficiency, so that thing can be easily done using the ANSYS OptiSlang. And you can also co-simulate, and multi simulation is also possible in that. Like you can design your model in ANSYS Maxwell, and that can be imported and exported to the MotorCAD, and from MotorCAD to ANSYS is also possible. So that will basically speed up your motor designing, and you can easily able to test your motor efficiency and the performance in both the system. And we can also do the FEA analysis for the EMAG, the electric machine, for the flux density plot. And after going to that designing part, first we will go to magnetic analysis. So in that magnetic analysis, what basically we required a tire, torque, power, and packaging, and in that we also want cost reduction and robustness. So like if you have selected a magnet material, and in that material if I will provide certain amount of current and certain amount of voltage will be provided to that motor, what was the value of demagnetization and hysteresis, and what is the screwing value, so that thing will also have to be considered when we are going for designing our modeling or changing the material. Like if you want to change your material, so of the motor like a stator and rotor part, so that thing can be easily done in this answers Maxwell. And we can also do the scalability analysis using the HPCs. HPC is basically a high performance computing for the electromagnetic models. So that will basically, when you add the number of cores, you can see here like from 1 core to 24, this will basically increase your or reduce your timing. So like continuous solution using the answers Maxwell will basically reduce torque ripple by 90%, like cogging torque is there for the permanent magnet or interlocking between the stator and rotor. So that thing can be also be considered here. And after designing your model, we just want what was the efficiency and what was the efficiency curve we are getting, and what was the torque speed curve. So that thing can be easily designed in the ANSYS MotorCAD and ANSYS Maxwell also. By using that ANSYS ACT machine toolkit, we can easily design it and we can easily predict the behavior of the efficiency and the torque speed curve. And that blue dots are basically a driving cycle we have put it. Like if we check for the point value of this value, so what was the behavior of my and what was the efficiency. So this side we are plotted a efficiency curve, so you can also check the efficiency. If I am running my motor at that particular speed and that particular torque, what was my efficiency, so that thing can be easily considered and accurately predicted. Like you can also see the Magna Electronics is basically predicted that is their experimental data and that is their simulation data. So that simulation data basically accurately predict the electromagnetic performance, uh, like I have discussed it right now. So you if you you simulate your model and efficiency map, you will get like this. So this will basically match with the experiment data, so you don't have to worry like what was the performance of my motor when I go for hardware design. So that thing can be reduced it by using this. And in thermal management system, like how to provide a cooling to our motor, and so that thing will be also a very important thing. Like if your motor is running for 2 and 3 hours and it get heated up to certain level of temperature, so that thing can be easily reduced, and we have to first analyze the what type of cooling system I have to use. Like we have already designed for the battery, so the same method we basically have to follow using the ANSYS Fluent and ANSYS HPCs. So these things we have to be considered when we are going for designing for the cooling system of the our motor. So we have to also taken care of the thermal reliability and the motor life in this. Like our one of the customer Lucid Motor has already cited that this will basically increase their energy efficiency of the motor by 12%. The temperature prediction basically predicted matched physical measurement with within a 3% margin of error. So you can what benefit you will get basically, like you can all effectively cooling system can be created, and you can always easily able to predict the temperature distribution. You can in the winding and lamination and in the electromagnetic and thermal interdependency can easily be calculated in that. And the one of the most important thing is the noise and vibration harness and structural integrity in that part. Like if you are sitting in your electric vehicle and you are getting a noise of your motor, noise of the battery system, and noise of the and inverters used in the electric vehicle, so that will basically annoy a passenger which is who is sitting inside the electric vehicle. So for most importantly that we have to make our system like that noise will not basically affect our first, it will not affect our system, whole system, and second, it will not annoy the passenger who is sitting inside the electric vehicle. So that thing also we have to be take care, and the consideration part, like you can see here, what we have to do, we have a electromagnetic model of our motor, and that will be given to the MBDs and multipotent dynamics, and from there a gear system is connected, and you can give that system to the sound quality, and for the structural harmony to the VR sound quality. So that will be taken care, and VH characteristics curve and the waterfall diagram, you can say for the noise and vibration analysis, we have a waterfall diagram. So that diagram we have to be take consider, and we have to be taken into the account when we are going for acoustic simulation based on surface velocity. So that thing will have to be considered when we are going for designing the noise and vibration analysis for the electric motor. So by doing that, you can also optimize your noise, and you can also reduce the noise up to certain level. So that thing will be make a passenger a comfortable ride. And the next thing, we are basically have to give the multi-physics traction motor design optimization. Like the word optimization is used here, this means optimization means optimized, like if you have a power and torque curve, and the cost of the machine, and what was the material of the machine, and what was the heat it is get generated, and what, so these things we can easily do by using optimization technique. Like how, what was the range of the temperature we can easily set, and we can also set the performance, so that we can make a trade-off between these two. So like my motor can reach up to 100 degrees Celsius or 150 degrees Celsius. So that thing will be taken into the consideration when we will designing our traction motor for optimization part. And this will basically help you by using the OptiSlang. We can easily 2 and 3 parameter can easily be optimized, and this will basically increase your efficiency and torque, and this will also help you in reducing the size of your motor, and this will also help you in make your motor quieter, and this will also reduce your timing of the simulation. And after this, we have to control the whole integration system, like we have designed our motor and how we will validate that. So for that, what we have to do, we have to just export and import to the lookup table generation, and from there we have to do the ECM extraction to the tweet builder, and reduce order model technique is there for reducing that model. And then we have to do the HIL method. So that HIL basically a hardware in loop integration part is there. So that will basically help you to give a real-time simulation type data. So for your analysis, so this will basically make a interaction between component. You can easily able to understand that. You can also validate your system response for the control strategy which you are basically using, and you can easily tune and optimize your whole design of your electric vehicle which you have designed. And then we will summarize the whole process of electric machine development process. So in that process, the first thing what we have to do, by using the MotorCAD, Maxwell and RM Expert, we have to design a motor, and after designing the motor we have to do the thermal, mechanical and efficiency mapping of that motor. And the next part what we have to do, we have to do the FE analysis of the motor, and for that we require Maxwell, OptiSlang and HPCs. And then we have to go for noise and vibration analysis, and in that we have to check what was the value of the noise it is producing, and how to reduce to that, and what was the cooling technology we have to use, like air cool system or any liquid cool system. And after that we have to go for validation part. So for validation part, we have created a motor, and that motor will be given to the 3D physical validation, and from there we will validate our whole system. And then for the like if you already have a battery of 48 volt, but you required a 600 volt for a motor to run a motor. So for that, what or you have a music system in the electric vehicle, you just have other things is connected in the electric vehicle for comfort. So what you have to do, you need a power electronics device there. for controlling and for making your system will be working fine for the other things, a multimedia, that things will be connected. So you have to design it like that, like that will not affect one system, will not affect the other system behavior. So that thing you have to also take care. And in that system, power electronic system, that power electronics devices are very much important, and the kind concern when you are going for power electronic switches, it will create a harmonics in the system. So that thing also, mitigation of harmonic is also a research area for many people. So that will also we have to take care. And after that we have to check the what was the increased power density and the lifetime, and how we will reduce the losses, and how we will basically reduce the noise, and over voltage protection will be provided. So for that we required a electrical, mechanical software, and electromagnetic and thermal team for completing that whole power electronics device design and development part. So in that, if we decide our circuit part, so that then electrical people will come with the knowledge of that optimized system and the circuit design. And for reliability we have to go for that, like what was the PCB reliability which I have designed, and what software like embedded control, like design and testing, like if you are controlling by using GSM model in your mobile phone, and from that mobile phone you are giving a signal for that to control your electric vehicle. So that thing will be a very important point when we are going for your automatic electric vehicle designing part. And then we basically required a magnetic analysis for our power density, and for the cooling system design we required a thermal management and EMI EMC for the meet the standard. So the next part, or the main thing about the circuit, we what we have to do, we have to first go for that topology selection, like which type of topology and which type of converter or which type of rectification we basically required. Like if this is a flyback converter, as an example it is used here. Okay. And what was the switch you have to use, like for example IGBT, or I have to select MOSFET, or I have to go with BJT and triac. So that thing we have to be considered and like topology of the switches, which switch basically help me and help me to get a better result, and which it will basically affect my whole system, and what was the switching frequency uh, of the model. So that thing also are very important when we are going for optimizing and designing our circuit. So for the multi-domain circuit, and the system can be exported using the twin builder, we can easily use that multi-physics analysis. And from that, the next part we have to use, like ANSYS SCAD option is there. And there what we will have to do, we don't have to do anything, that will basically convert our system or the Simulink or the twin builder model to code, and that code will be used. And one more thing we can also, I like to add here, we can also do the third party system modeling. Like if you have created your model in GT suite and the MATLAB Simulink, so that can be used also as a multi domain system, and that system will basically help you in designing your complete EV package. And one more thing I would like to add, like this will basically benefit you, like enable border application range. This will basically increase the competitive advantage. This will basically reduce the less reduced failure due to thermal stress. So that analysis can be easily done in this. Like you can see, go for go for a switching selection. Like if you have selected a transformer, electronics transformer, or you are going for IGBT selection. So what was the behavior of your IGBT if particular amount of voltage and the current is given to the IGBT? So what was the behavior, like how much heat it will generate, and what was the can if due to heat no short circuit or open circuit will be happen in the whole system. So that thing also be a very important, and we have to be considered accordingly, like skin effect and the proximity effect. So that thing also a important point for selection of power electronics devices or power electronics component. Like you can see here a thermal performance. For the thermal performance, if your IGBTs, MOSFET, or any switching device will be get heated or red hot spot is created. So that will basically give you a thermal limit prediction. Like you cannot go beyond that. This will basically make your circuit a short circuit situation or open circuit situation. So that thing we have to be easily and cost effectively we can already check it. And this will also reduce our when we are going for hardware designing. So this will basically help you in predicting or winding the losses can be easily helpful when we are going for real time simulation or real time hardware. And then we required a yes for the EMC certificate. You can see here our a red hot spot is created. A radiated noise prediction can be easily done using the ANSYS, and this will basically reduce the time and the cost of the testing by 20 to 40%. This will also give you information about the weak point localization, and this method will basically help you in detection and the mitigation of EMI and EMC effect easily. And for that ANSYS will be provided with the library component of EMI and EMC. And you can also check what was the frequency dependence parasite is present or not. So that thing can be easily detected using this test. And then what next we have to do, we have to go for like live prediction of our design and what was the PCB reliability. In that PCB reliability, how to mitigate the failures of the component which we have already designed for our controller and for the controlling part, and how to reduce the cost of that material and whole component. So that thing will comes under the PCB reliability. And you can also by using the single platform and using the CAD library, so you can easy and the ready to go model type system will be present there, and from there you just have to export that, and that will basically help easily to predict the lifetime prediction for that PCB design. And let's summarize this whole process. Like first we have to go for using the twin builder. We will design in the simpler part. You just have to design your behavior of your whole system, and after that you just have to select that switch like IGBT or the MOSFET switches. You just have to give the behavior real time behavior to them, and then we have to analyze what was the behavior of my switch when we are using it in this particular voltage and the current. So and after that what how much value of the heat it will generate, and what type of cooling system we have to require using ice pack. So that will be given, and after creating this we will give to that for the analysis like PCB designing. So after that the next thing is the thermal structural and reliability test, and after doing these tests we will have to go for driving cycle integration and the functional safety and optimization part. And after that the creating that and doing that optimization, we just have to connect our whole system. The next step we are basically have to focus on the giving the information, and we have to just connect it. So that thing we have to be like we have already designed our battery and the battery management system, we have designed our motor, and now we have designed the power electronics component and controlling part for the motor. So now we have to just cascade all the system, and in that what we have to do, we have to the like powertrain system integration part is there. In that power system integration design basically required a system integration of component validation and system architecture. Like we have already validated our component, and then what we have to do, we have to go for system architecture part. In system architecture part we have to just connect it all system and go and do the core simulation to check the results. Okay, what was the behavior when I'm connecting what I have designed and I am now connecting, so what was the behavior of that system. So that thing we have to becomes under the part of system architecture. And in that we also use the third party ecosystem, and we also use the motor generation for the CAD software. And we will also give a bi-directional, like if you have designed your electric vehicle and you just cascaded all the system battery, motor, and power electronics devices. Now what you want, like if you just want to go from switch reluctance motor to induction motor, or you just want to change it from internal permanent magnet IPM motor to other changes, sorry, you basically want to change, so that thing can be easily done in the system architecture part. In that system architecture you can easily do that things, or your model or prototype will be designed, you just have to change any model or any component there. And then we have architectural definition. In that we basically defined it in four parts, like fluid cell library, liquid cooling library, heat exchanger library, and vehicle dynamic library. You can change the position of that powertrain integrable component and subsystem. You can change the position there, you can also change the material in the fuel battery, you can also change the like cooling system, you can also change the what was the vehicle dynamics you are basically interested in. Like if your motor is running in a motoring mode and you want to check the what was the behavior and how we will connect it when we are sliding our motor, and for that regenerative braking mode, so that thing will be easily changed. And if you want to change your battery performance, so change from lithium air to fuel cell, so that thing can be easily done in the fuel library system. We can basically created, or you basically created a reuse of existing design. So just you have to change the parameter definition, and after changing that parameter definition, what this will basically help you, like you have designed your electric vehicle, you just have to change the material, so this will basically save you 50% of your time in construction of the system architecture. So this will basically help you in going for designing of electric vehicle. And the same thing, like how to increase or the make our system to run fast, or how to simulate our system to behave run fast. So for that, what we will do, we will do a high fidelity and reliability modeling of the component and like we just change it and export our model or the parameter things as a function, or the measured value and the design experiment value can be exported, and then validated 3D physics can be also exported for the validation and specification for the architectural and the subsystem and the optimization design, so can be done easily. And for that, what we have to do, you just have to use the reduced order model function based measurement in the twin builder. So from there we will do the co-simulation there, and this will basically increase your 3 order of the magnitude speed up to the 3D fidelity. Well, and this will basically provide your reliability of your system will be presented here. And you will also come to know about the embedded software certified, or and this will also reduce your timing, like time to market. And this will basically provide you like if you are going for V and V workflow, so that validation values and validation part will be easily done in the whole system. And this will automatically generate a code generation part is there, so that will basically help you to generate a automated code high level, and you don't have to waste your time in creating a code. So that thing also be presented in the embedded software. And then we have to go for system integration part. In system integration, we just created a battery, power system and motor, and we can cascade it in this. And after cascading and connecting embedded software and the control system and inverter subsystem and the magnetic component, what was the behavior of my whole electric vehicle will be considered here. And this will also reduce the hardware in loop cost. This will also increase your virtual drive cycle performance and what was the behavior, so that can be easily understand in this system integration part. So whole system will be simplified as like first we have to do the architectural part of the whole system integration, and then we have to go for real time modeling of our designed EV, and then we have to go for subsystem designing for the reliability and thermal and structural analysis. And after that, when the whole system is created, we have to go for system validation part. And for the system validation part, we require a driving cycle. So lots of information about the drive cycle is already available there, or you can also put your information about the drive cycle there, and you can also create a table like for the speed and time curve there. So that will be also important for the driving cycle, and from there you just go to that safety function and optimization. So these things can be easily done in system validation part. And for the research point of view, we have listed these research topic topics here, like for the electric machine, new topologies like functional safety, reliability, motor control, and motor thermal and motor noise and vibration analysis. So these things can be done as a research area. For the battery pack, you can change the material of the battery. You can also change the what was the functional safety will be more in your battery pack, and the what was the cell chemistry is behind. So like if you are going for bi-directional supply, like from solar, if you want to run your electric vehicle, so how to design that electric charger for this battery. So for like wireless charger is the hot topic right nowadays. People are very interested in doing that research of the or research on the wireless charging. So that thing also be in the very important topics and the research topic people are interested nowadays. And for the power electronics part, they will basically interested in how to create our power system and reduce the harmonics present in the switches, and what was the switching loss, and how to reduce the number of switches in the inverter and the multi-level inverter system. So that thing also are very important topics for the research area for the power electronics peoples. And then we have to go for that system integration. What was the safety of the whole system? Like you have created an electric vehicle and that will be running perfectly fine, but anytime if crash or accident happen, how the your electric vehicle will behave at the time of accident. So that safety and reliability part is very important at that time. So you just have to take care when you have going to designing, and when you are getting take care of that part of your electric vehicle. And these are the list of some opportunities for the student for the multidisciplinary part. Like if someone is interested in battery design, so then that these departments are basically involved in that. Like if you are interested in traction motor designing, so electrical, mechanical, and aerospace, automobile and electronics people will be very keen to know the behavior. And for the fuel cell, chemical peoples and the automobile and the material science and the mechanical peoples are very interested. And for the power electronics and the system engineering and the fluid flow, so these are the basically top technology discipline and the departments which we basically listed uh, for the electric vehicle technologies. And these are the job opportunities for the electric graduate with the LEV skill. Like they can also do the scientific research for the battery for, and they can also do the design and development, and they can also do go for manufacturing and maintenance part. They can also develop an infrastructure for that. Like if you want to run your electric vehicle with electric charge supply, and then you cannot say like that, "Ki, I am using the green energy," because the coal and the other systems are already used. So you have to go for reliable system and the renewable energy system like wind energy. So that should be implanted. And for the green energy part is very important this point of view for the infrastructure development for that. If you have created electric vehicle but charging point or charging station is not present there, so that thing also are very important when we are going for designing our electric vehicle. And the sales and support is also important for the for a good opportunity for the EV related skill if you have in your CV. And last these are our customer usage, so that they are basically reduces and increases their motor efficiency by 12% by doing the thermal analysis and reducing the temperature impact on their motor side. And these are the basically a learning path for the answers people. Like first you have created a concept, and in for the creating a concept, Hanses will provide you AIC course curriculum, and then ALH will be provided for guide you like how to design, and these things you can use that in using the ALH information. And then you can go for experimentation and the validation of your whole electric vehicle or EV design, and you can use this experimental method for all other techniques which you are basically interested in. And this ANSYS will basically provides you a list of platform and the list of the best of the breed simulation across the multi physics, all the all major physics in single platform of the workbench, and like fluid structural electromagnetic and semiconductor power divide devices for the semiconductor and the power electronics devices, and the all material information is provided in by using the granta material. ANSYS basically acquired a granta, so from there you can all easily get a materials like metal, non-metal, and the many other information are present in the material informative part. And this AIC is basically ANSYS innovative course, and that course is basically used for high school, undergrad, and early graduate level peoples, and that courses are basically complementary for the ANSYS professional peoples. ANSYS professional courses are there for increase your value in the market, so that can be also be used as and who will develop these AICs? AICs are basically developed by the real-time engineers. They are basically working on OEMs and the healthcare and aerospace customer and the chemical department. So that peoples are basically engaged in creating or for making basically a learning platform or provide basically a curriculum or the content for creating a great content for your learning and for the learning of high school and undergrad peoples. And ALH is their learning management system is present. ALH is the ANSYS learning hub, and this ANSYS learning hub basically guide you like if you are interested in electrification like a EV part, and if you are interested in any other things, you can easily do using the ANSYS learning hub. That ANSYS learning hub is basically a self-paced learning videos as present there, and you can also go that collaborative learning rooms are present, live class rooms are present, and the virtual classes are there, and the more than 240 plus course materials and 1000 plus workshops are already there in ANSYS learning hub. And these are the job opportunities for the multi-physics disciplines, you can also say that for the scientific research, for the design and development, for the manufacturing and maintenance, and the infrastructure and the sales support. And these are our some academic success stories. Like we track at Spark, we have created a center of excellence on electric vehicle there, and that will be in Kerala, and we have divided this in three phase. Like first we have gone for motor designing, and then we have started the phase two for the power electronics, and then the next phase is left for the battery, and the battery management system is there. So we have to design that using that ANSYS part. We are basically doing a statewide workshop on EVs, and we are collaborated with AR AI collaboration is there, and in that AR AI collaboration, peoples are basically creating a center of excellence for the EV and ADAS, and that will basically help. And you can also do the startup, and you can also get the fund from for the startups if you are going for that and designing your EVs nowadays. And these are basically IIT Bombay teams, and that will basically you are just and they got overall fourth out of 73 participants, and they are basically used ANSYS for designing their car. And we are basically ARK Info Solutions, and we are these are the works brand basically we are working for, and we are working with these techniques, and these are the our team, and we have 80,000 plus satisfied customers. Thank you, and I am open to any Q&A.
Yes, sir. So in today's session, sir gave an importance of design and development of electric vehicles using ANSYS software with the help of different examples. Hope you receive all the information by this webinar. At the end of this webinar, I would like to express my gratitude to all viewers of the webinar for their online presence and to make this webinar a great success. I extend my gratitude to our today's expert, Mr. Katikesh Kumar Jha sir, to take out time from his busy schedule for this informative session. Thank you so much, sir. Thank
Thank
you.
you, sir, for giving me an opportunity, sir.
Yes, sir. Thank you, System Department Cell of Parul University for nice support. Thank you, Bridges sir. Thank you, everyone, once again. And we conclude our session here. Look forward for same support in future. Thank you so much, sir.
Thank you all
Thank you all.
for attending this lecture or webinar.